You good? Good to
Yes,
go? Awesome.
good to go.
So hi everybody. I'm Scott Werner. I'm the CEO and co-founder of Sublayer, where we've built a product management app that brings the full power of generative AI to your product development process. So a lot of the stuff we were just talking about, we're kind of implementing in from the product management interface with the idea to kind of streamline that and cut out a lot of the tedium that exists now because generative AI can write a lot of that code for you. My talk is here to share a lot of the principles that we've realized, because pretty much since like the third day we've been using Sublayer to product manage Sublayer, and so have run into things that didn't work, things that do work, and some high level principles have come out. I'm going to share those and share some of the things that I feel like I got really was able to internalize through using Ruby and Rails, and things that seem very likely to be things that are very important when generative AI is doing a lot of the work that we've been doing. And so just real quick about me, I've been a professional Ruby developer for the past 10 years, from big companies to startups as an engineer, manager, and founder. Even this latest startup decided to use Ruby for the back end. And I've said many times throughout my career and still firmly believe that Ruby is my competitive advantage, even in this future where we might not be writing as much of it as we have in the past. And so one of the first kind of sets of principles that have come out is something we're calling promptable architecture. And so the idea here is that if you change the way that you build your applications in such a way, I'm trying to move this around, in such a way that makes it easy for you to write simple prompts and get working code, you're going to have a competitive advantage, right, against people that are, architecting applications in ways that aren't, or building things that aren't easily promptable. And so from that, handful of principles that might seem familiar have kind of come out, and it seems like these are kind of a start, not comprehensive by any means, but like kind of the first ones that seem really promising. And so this idea of component-based design, kind of thinking from like a React component standpoint of this is a button that when you click it, it changes looks depressed, it does an action, and as you break your software down into smaller and smaller pieces, the prompts are smaller, you can be more clear about what you want to happen when a user interacts with it. Self-contained functionality, very similar, that if you have to write a prompt that's like, I changed this, and then I changed this, and then I changed this, and like all of these other files need to change, you're going to blow up that context window. You're going to have a lot of code to review that comes out. And like we talked about, like sometimes it hallucinates stuff and sometimes it gets things wrong. And for the same reason that smaller PRs are better, even when people are writing them, smaller PRs are a lot better when generative AI is writing them. Like I would much rather review 20 lines of code written by ChatGPT than 2,000 lines of code written by ChatGPT. Much more than reviewing 2,000 lines of code by the person sitting next to me, right? And then the third thing is the clear interfaces and clear contracts become even more important in this world, where you're able to say, really, in a concise way, this is the input, this is the output, these are the actions it can perform, and it will cause you to start to think about the code more like that if you're not already. Which I kind of hinted at this, that like all of these things are things that you probably should be doing anyway, but I see them being more important. And this line from Alan Kay sticks in my head: a change in perspective is worth 80 IQ points. That we're for a while we've been looking at these things as like, these are principles of good code for X, Y, and Z reason. We add another perspective, we look at this from another angle of, I'm doing these things because I'm going to send these prompts to a generative AI, to an LLM, it will allow us to think about them, learn them better, internalize them better, and maybe even like realize new things that we couldn't even realize. Think new thoughts that were unthinkable before because we're adding this extra perspective. So even though these aren't groundbreaking new ideas, it's more coming at them from a new direction is where I think is important. Which brings me to the thing. So three core ideas that I see surviving in the future from Ruby and Rails. And I think one of the big high level concepts of where these came from is the idea from Avdi Grimm's talk, the soul of software, where he talks about the dichotomy in software between the formalist school and the informalist school. And so you can kind of, he uses a reference from a book, Object Thinking, that, you know, if you were taught OO, if you were taught inheritance when you were learning OO first before polymorphism, you were taught by a formalist. If you were taught polymorphism first, you were taught by an informalist. Because the idea of the formalist school is like putting things into boxes, like the static typing and organizing things, whereas you know, the meta programming and monkey patching and all that stuff in Ruby doesn't really fit in the formalist school. And so here's a couple other things that don't really fit in the formalist school that I think are also going to become bigger and more important in this world where generative AI is doing a lot of the coding. And so, Andrew, we talked about this a little bit. You know, in the Python, for example, there being one true way to do it, with LLMs not being deterministic, being comfortable with, yeah, that works. It's not how I would do it. It's not the one way, but we get the output that we need. That's fine. And so like with Ruby, you know, we've got aliases for methods. You can use mapper collect, you can use reducer inject, whatever you like, right? You can do select and reject, you can do if or unless, even with active support, taking that even further with like all of the array access methods up to, you know, up to 42, that it gets the job done. The actual details of the code matter less. There's aesthetic choices that we would use in Ruby, but I think it's more that, you know, you have more than one way to do something. It doesn't really matter that much if it's done in a few minutes, right? And so like for the same reason that, you know, when we're moving to, you know, compilers and people being like, oh, the compiler's never going to you know, write the optimized assembly that I can, which for some areas that might be true, but it might take that person 2 weeks, whereas the compiler's done in 2 hours or something, right? And so you kind of got comfortable with the large majority of it just works. The large majority of it is performant enough. You can drop down and fix the parts where it's not. And that's first thing. The second thing, which, you know, is very similar, but this idea of duck typing, where quacks like a duck, walks like a duck, quacks like a duck, it's probably a duck. I'm still trying to come up with a good term for this. The best I could come up with was duck product, where passes the tests, it passes acceptance, it's performant enough. I think the feature's done, right? It like the details don't really matter once those higher level ideas are there. And, you know, similar to what I was talking about around like giving up control and like the informal perspective, like I don't need to know the type of this thing if I can call these methods on it, if it has these behaviors. And I don't need to know the details of the code of this feature if the requirements are all passed. The onus is on you for writing the requirements, but the newly lower level details become, you know, I think less important, and getting comfortable with those details being less important is only going to help. And then another thing that we touched on in the beginning, but the idea of you know, convention over configuration, which I mean, barring the last few years with some of the stuff that Next.js is doing, we've kind of lost that idea for not Ruby and Rails, but like throughout programming, and like things have become much more configuration heavy, where, especially for what we're doing at Sublayer, conventions make things a lot easier for, you get to a place where, I know the models go here. I know they're capitalized this way. I know the inflections are this. And when you write a prompt of, make add a new model, you can or do something with a model. If you've connected your GitHub or you're connected your repo, we can look in that folder. We can know that these things are there, make the changes, and make the PR in the right place. And so, I see as these things evolve and as they become more powerful and we discover more patterns, that convention is being able to invent conventions, rely on conventions, is going to be more and more important, and more the way that you kind of get things that, even taking a lot of us a few hours in minutes. And I was joking with Trace last night, we could even start thinking about like convention oriented programming of like the challenge is more like, what's the convention for this set of features that we can then feed into the generative AI, and just know that things are going to end up in the right place and work, because we don't have to like create special cases for each one or give it extra data for each particular thing. And then, an off by one error. Also, the culture of testing, I think, is also going to be an advantage going forward. Promptable code shares a lot with testable code. Partly, I think, I spent a lot of time writing Cucumber, but like you're essentially doing that and thinking about your code from a higher level of abstraction when you're writing, given this state of the world, when this action happens, then something else the state of the world should be updated, right? And that's very close to what you're doing when you write a prompt to get an LLM to write code, right? Given these files that have this content or this, this code, I want to add this new feature to it, then I should, I expect the code to be changed, right? And so that's only going to help because you're already thinking about the code from that other angle and that other perspective. But that was a very, very quick talk. I know it was much shorter than usual, but I knew this was like a very hot topic, and I wanted to leave the end here open for questions, discussion, and I would love to hear what all of you think and how you've tried to use ChatGPT, Copilot, and everything in your workflow. Thank you.